everyone, we're going to show that the function y equals a times e to the negative x plus bx e to the negative x satisfies the differential equation y double prime plus 2y prime plus y equals 0. All right, so basically what we're going to use is we already have our y, we need our first derivative and our second derivative. So let's just take the derivative of y. And remember, a and b are just constants. And also the derivative with respect to x of e to the negative x, because we're going to keep running into that. This equals negative e to the negative x based off this. So we're going to be using this a lot. All right, so let's get started. So the first part, if you take this derivative, that's going to be negative a e to the negative x. All right, and then the b part, we have to use the product rule. So it's positive here. And bx, derivative of b to the x, is just b. And then you multiply it by your second part. And then plus, copy down bx. And then the derivative of e to the negative x is going to be negative e to the negative x. So I'm just going to go ahead and move this negative. I'm going to take it out here and make this a negative. Now let's do some grouping here by factoring out a e to the negative x here. Now I'm going to go ahead and write b first. So let's write the b first. So I'm going to write b minus a times e to the negative x. Mainly because my b was positive, so I wanted to write b first. And then you have minus b x e to the negative x. That's your first derivative. Now, the second derivative. Again, b minus a is a constant. And if you take this derivative, you're going to get negative b minus a e to the negative x. And I can switch this around because this is negative b plus a. So I can switch this around and write this as a minus b e to the negative x. Now, for the second part, we're going to get minus, take the derivative of bx, and that gives you b e to the negative x. And then the second part's going to be the same as what we had before. So it's going to be plus bx e to the negative x. All right, looking at what we have here, we have two of these. So I can rewrite this as y double prime equals a minus 2b e to the negative x. So that's what this would be. I just factored this out, and negative b minus b is negative 2b. And then we have our plus bx e to the negative x. Now we have our second derivative. So let's substitute everything in and see if we get 0. So we have y double prime. So that was a minus 2b e to the negative x plus bx e to the negative x. Okay, and let's write this plus 2 times our first derivative, which was b, let's do this, b minus a e to the negative x minus bx e to the negative x. All right, and then our y. So this is just your y. So copy that down. That's plus a e negative x plus bx e to the negative x. And this should all equal 0. All right, now let's go ahead and simplify this. Let's go ahead and distribute this out. We have a e to the negative x minus 2be to the negative x plus bx e to the negative x. And then for this part, let's just go ahead and write this as plus 2 times b minus a e to the negative x minus 2 bx to the negative x. Then we had still our plus a e to the negative x plus bx e to the negative x. That all is supposed to equal 0. So what I can see right away is I can get rid of these b's. I have bx e to the negative x plus bx e to the negative x is 2 bx to the negative x, and then you minus it. So now we're left with these. All right, this one, and this one. So let's write that out. A e to the negative x minus 2be to the negative x. And this is going to be plus 2be to the negative x minus 2a to the negative x plus a to the negative x. And that should equal 0. All right, now let's see what we can do. So we have 1, 2 here. So that cancels out with this negative 2. And then this is clear. This equals 0. So we did get 0 equals 0. And luckily, we got it right. Thank you. Have a nice day. Bye-bye.